What's up, guys? Mr. Yates here. Today I want to talk to you about an area word problem. So let's take a look at our problem for today. Mr. Yates is building a rectangular garden that has an area of 12 square units. What are some possible side lengths of his garden? Now when I read through this, I read a kind of funny sounding word, this word right here, rectangular. But that word isn't actually so funny. It's exactly what it sounds like. A rectangular garden is a garden shaped like a rectangle. And that's important because later on when we want to model our math and show our thinking, we need to make sure that we're drawing gardens shaped like rectangles. Now let's take a look at the question. What are some possible side lengths for his garden? So I am looking for side lengths that will help me answer my question. What do I know about side lengths and area? Well, I know that if I take my two side lengths and I multiply them together, I get my area. So I need to look for two numbers or two factors that are going to multiply together to equal 12. So the first set of factors that I can think of are 3 times 4, because I know that 3 times 4 is 12. So I'm going to draw a rectangle-shaped garden, and I'm going to label it 4 units on the top and 3 units on the side. And now I know this works because 3 times 4, or 4 times 3, gets me 12. But I want to be a bit more thorough than that. I want to draw on my actual unit squares to kind of show my thinking a bit more. So I'm going to draw a row across the top that is 4 units. So 1, 2, 3, 1, 2, 3, 4 square units. And I want to make sure that that repeats itself 3 times going down the side. So here's 1 row of that, 2 rows, 3 rows, and I'm just going to continue these lines. Awesome. And now I can just go back and count to prove that this is going to have 12 square units. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Awesome. 4 units and 3 units are 2 possible side lengths that would make my garden work. However, and here's the fun part, those aren't the only answers. Because some of you may have been watching this thinking, well, I know 2 times 6 is 12, and you're absolutely right. We could also make a garden that's 6 units by 2 units. So let's show that as well. This garden's going to be a bit skinnier, but also a bit longer. So we're going to label it 6 units on the top and 2 units on the side. Cool. And I know that this works as well because 2 times 6 or 6 times 2 is going to give me 12. Those are both factors of 12. Cool. And again, I'm going to draw in the unit squares because I think that helps show and model my thinking even more. So I'm going to split it so now it has 2 rows going this way, and I'm going to split each one of those rows into 6 units. Cool. And again, we can count just to prove that this is going to give us 12 square units. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Awesome. So we found more than one answer to this word problem. And to be honest, we're not even done yet. There is one more answer. That's a little tricky. But let's look at this. What if I had a garden that was really skinny and really long, and it was 12 units long and 1 unit wide? What's 12 times 1? That's right. It's 12 square units. That also works too. And if we wanted to draw in those lines to show the unit squares, we could. 1, 2, 3, 4, 5, 6, 7. Cool. And this is going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 square units. Awesome. So another set of answers would be 12 units and 1 unit for side lengths. Well, I hope this helped, guys. Good luck.